jump in right into it. I'm going to run through, well, thanks for attending my workshop, guys. Nice to meet you. My name's Sarah. Very cozy crowd today. I'm going to be running through, so I'm originally from Filecoin. We're working for the Filecoin project, and we're currently building out a scalability solution. If you've been building on Filecoin, we launched a Filecoin virtual machine last year, which allowed people to start building on Filecoin, but block time was a little bit slow. It's about 30 seconds, kind of like Ethereum needing like a Polygon layer for you to scale, right? So we're building a scalability solution right now, targeting Filecoin first, and then it's designed to be natively multi-chain. So we'll be moving on to Ethereum and then Bitcoin and probably Solana right after that. So that's kind of on our roadmap right now. Super MVP, we have been very experimental with this, was just fixing the quick start as we came into this workshop. So a lot of new things to try. Just kind of want to put it out there during this week in Denver, get some feedback on how it's working. We have some bounties in the, any of you guys hacking at the Buildathon? No? No one's hacking? Okay, cool. Yeah, so we have some bounties there if you want to participate, but there's a super easy quick start and we just built a Docker image to make it even easier because Rust takes really long. So I'm going to run through the quick start. If anybody wants to take out their laptops and try it out too, the link is available for you to follow along. Yep. So yeah, some goals for today. Going to introduce IPC, which is Interplanetary Consensus. Name might change, but it is our scalability solution right now. Everything is TBD, but we believe in bringing alpha builds and trying to see how people want to build it out with us. So I'll share some really cool links later on. We'll deploy our first IPC custom subnet, and then we'll see what some use cases are for you to build. And also, if you guys have any suggestions, help us build out that list. I'm going to share some cool ideas we've had with our engineering team. And then if you guys have more ideas, we're going to keep adding onto that list and building out some really cool demos. Alright, so Interplanetary Consensus for dApps. Here's a quick introduction to what you can do. We built it to be hyper customizable. We use Tendermint under the hood, Tendermint Core, and we call it Fendermint because it's an adapted version of Tendermint Core. We don't use it with the Cosmos SDK. We have left it open right now. We're mostly building with Rust. We want to allow people to use any framework they're comfortable with. So we call it Fendermint, so that's running under the hood. Our execution layer is the Filecoin virtual machine, which I mentioned earlier on was launched last year with Filecoin. That was built with WASM under the hood, so you can use any language you want on the execution layer as well, and on the core instance of IPC. So everything is hyper customizable. We've left it pretty open-ended for how developers want to use. And the goal here is to enable horizontal and vertical scaling. So you might have heard of some solutions like maybe Arbitrum, you can do like vertical scaling, horizontal scaling, so you can create different blockchains, custom blockchains. For us, we do horizontal and vertical. I'll show you a little bit on what the vision is later on. Vertical means you can do L2+++, so you can build like L3s, L4s. The way they are all connected is through hierarchical consensus. So whatever consensus you're running on, let's say your L4, L5, so on, will roll back up towards your L2s and back to your root chain L1. In the same way, it inherits the security features of your root chain. So if you are building on a trusted root chain to begin with, that trust kind of trickles down throughout the rest of your subnets. So that's really the goal here. Horizontal scaling is so that you can build up various subnets. We also make them dynamic in the sense that you can spin up a subnet, shut down a subnet as fast as you want. So if you want to create one for transactions, maybe for a certain task that you want to run on your dApp, you can spin that up and then you can shut it down and you can save on gas and efficiency and cost, right? So that's really the goal here. We call them parent and child subnets, and that's why when we deploy, I'll walk through the quick start later, we're deploying our first child subnet. Yeah. Mentioned multi-chain, and yeah, let me show you a little bit of how we expect it to be working. So this is kind of a diagram of how we see it happening. So if you look over here, you have your mainnet root chain that you can choose. Again, designed for multi-chain. Right now, we are targeting Filecoin first, which means that we're putting a lot of work into enabling some storage protocols that you can do on Filecoin today onto your subnet. So maybe if you're using Filecoin today, it might take you a longer time to create a storage deal, right, to store something archivally. If we bring it onto the IPC subnet, block time there can run up to about 1 second. I think 30,000 TPS or so was what we kind of calculated. Again, this varies, but you could run that much faster. Of course, for finality to hit Filecoin for your data to actually be stored, that could take a little bit of a longer time. But on your subnet itself, the transaction can be confirmed and run, and your dApp can continue running. So that's some ideas that we have. So you can choose your mainnet L1 here, and let's say you run a gaming subnet over here and you want to shard your database subnet for your game onto a separate ecosystem. You can do that with horizontal scaling. So you're moving one layer down to the L2s, and you can continue running. Let's say you run your gaming subnet here, you have sharded your application into different parts of the game here. You're pulling data across from the database subnet here. All this is enabled through cross-chain messaging. You can do that pretty seamlessly with IPC. Right now we have an experimental phase. I'll show the roadmap later on. We have single hop GMP. We're working on multi-hop right now, but yeah, you can do that pretty seamlessly. And then if let's say you have requirements from GDPR in certain regions, Asia, US, and so on, you can actually build out regional versions and contain it within specific to certain regions on how you want to run your game. So that enables like different options, customization options for dApp developers. So that's really the idea behind the IPC. Yeah. Any questions so far before I jump into it? Yeah? Okay. I mean, I'm here, you guys are here, it's a pretty cozy crowd, so if you have any questions, I'm happy to take them before we jump right into it. If not, we can always do that later. Throughout any time you can stop me. We'll run your first generic custom subnet here. So that's the quick start that I'm going to do, right? Not so complicated right now. Let's start with like ground zero. We'll deploy our first custom subnet. Also, just to give a sense of architecture, I mentioned earlier on, we run Tendermint core under the hood. We're also using APCI++, so again, you can always vote on your transaction before they execute it, more security there. We run FEM on our execution layer. And kind of under the hood that you don't really see, I think from a developer standpoint you already touched, but we use IPLD store. So that's also one of the reasons why we chose to use Tendermint core but without Cosmos SDK. We wanted to write our own application logic. But this allows us to use IPLD store. So who here is familiar with IPLD? Awesome, great, new guy, yes. So yeah, IPLD is really efficient for storage. So when you checkpoint your chain state from your child subnet to your parent subnet, we call it checkpointing, that's stored in the IPLD format. So all, like, you can checkpoint it up to you how you want to configure it. It could happen every 30 seconds. All this can be stored as a graph because of IPLD, so it makes it much more efficient. Message formats are also stored in the CID format. So these are things that we pull from Filecoin. CID refers to content ID. So it's really just a hash for your message. So that makes it much more efficient. If you want to just store the metadata of your message, what it's about, you can just store that within the CID list, store it within IPLD, checkpoint your entire state of your parent subnet. And so that's much more efficient for you to check, if you want to cross-check the history of your chain. Yeah. So we use that under the hood. Again, that doesn't really hit your developers, but again, that's how we bring gas costs down. Some things to take note of, you'll see, well, you won't see it in today's demo, but if you want to use like general message passing, you'll come across IPC Solidity actors. We have a few. The three main ones are gateway, registry, and subnet actor. So for gateway, that refers to the gateway actor that kind of controls the operations between different subnets. So from your parent subnet to your child subnet, we have a gateway actor that controls who spins up the subnet, who gets to join as a validator, and so on. And then we have the registry, which is basically like a factory for your subnet actor. Your subnet actor will be the one that runs each instance of a subnet. Yeah. So TLDR, these are the few actors to take note of. Won't run through it in today's demo, but we use Solidity actors, just so you get a sense of how the architecture is for IPC. For those who just came in, TLDR IPC is a scalability solution that we built originally from the team from Filecoin, but we're building it out to be multi-chain. Again, like Filecoin, people build on it, it's a bit slow, so we want to have a scalability solution, and we're trying to make it hyper-customizable. So we're going to build our first custom subnet. I'm going to walk through a tutorial. It should be 5 minutes now that the Docker image is created, if no issues persist. But if anyone wants to come scan this code, you can check it out here. I also have a link tree that makes it super easy, but I'm going to leave it here if you guys want to just scan that. So even if you're not doing it on your computers today, because I know that on tables, you can just walk through and keep me in check as I go through my tutorial. Okay, so let's run this. It spins up. So again, we're targeting 5 minutes. I'm going to make it super easy to run through this. It should be the case, so that you can do this too. So if you come to the tutorial, I'm running a Mac. It's up to you. You can do it on Linux too. We have some prereqs here that you can install. I've already installed all of this. So this should take you no more than 3 minutes or so. Homebrew, Cargo, Rust, Foundry, having all these installed would be useful. So once you have the prereqs done, there is a manual build here, which works, the manual builds for Linux and Mac. This takes like, because of Rust, this takes me like 15 minutes to compile, which is like, no. So we have a Docker image that was created probably like yesterday, but it makes it much easier for you to pull it down. So I'm going to show you how fast it is. Yeah, so all you need to do is just copy this, paste it in. Cool. So that's up to date, done. So much faster than the 15 minutes I spent before. You want to initialize the config. So we're going to run these few commands. Yes. Also, the second command I ran over here is because I was facing a certain issue. If I only ran this first command here, my IPC CLI might not be able to be accessed because it's running within a Docker image. So we're going to run this additional command here so that you can access it. Cool. So now we have that up, and we're going to check our config file. So this is we are currently working on deployment script to make this much easier. So you're going to see me go back and forth a little bit with a text editor, but that should be resolved within this week. Right now, this should show your config file. The reason why I opened this is because the gateway address and registry address from the Solidity actors I mentioned earlier on, these are constantly updated by our core engineering team. We've put a JSON blob over here for you to make sure that those addresses are up to date. Yeah, you just want to make sure that they're always up to date, right? So if it's different, like today it's the same, but if it's different from what it shows there, you should just go in and manually change that. Again, these will be significantly improved in the coming weeks, but this is right now our MVP. Yeah, so cool, making sure that that is in check. And what we want to do is to start to create our wallets. Again, this is Comet BFT, so we want to make sure that we have at least a minimum of 4 validators. But for the purpose of today's demo, I'm just going to create it for one wallet, and we're just going to try to get the subnet up and running. So yeah, we create a new wallet. You want to just make sure you have that captured over here. So your wallet address in, and then, so this is the finicky bit, which that deployment script will be really handy to have right now, but we're going to have it in a week. Cool. Alright, so we're just going to set it as default wallet. I'm just running through this step in case you're setting up 4 different wallets, but if you just have one, obviously that would be the default one. And then we're going to create our subnet. So a few things to take note of here. I'm just going to run through the different things. So minimum validator state, we can just leave it as 1. Minimum validators, up to you to set how many ever you want. Again, I've only created 1 wallet today, so I'm going to edit that to 1. Again, recommend minimum 4. Right? Bottom up check period. So these are the configs that you can do. These are basic customization. I'll show you a tutorial later on, which I'm not going to cover today, but if you guys are experienced and you want to test out configuring system calls, implementing your own built-in actors so that you can run different things in your custom subnet. You can even run ML workloads today if you want to do so. I'll show you a tutorial for that later on. Right, so you can check your bottom-up checkpoint period to be 30 seconds or more. You want to put in your wallet address here. Permission mode for your collateral. Permission mode is how validators can get power in the network. So there are a few options here. Collateral, static, or I can't remember what the last one is. But yeah, it really depends on how you want to allow validators to come in. So if it's static, for example, you cannot stake any more collateral than what you initially put in. Collateral, you can just increasingly stake it. And I think the last one is, I can't remember the name, but then only your operator will allow certain addresses to come in as validators. So not anyone can just come in and join your network, but this is your permission mode. And then supply source, we'll set it as native for now. This will allow you to do ERC20 tokens and so on. Yeah. So let me just pop in my address here. Cool, so we have that. No. One second. Once again. Okay, yeah. So a little finicky right now with the Docker image because again built yesterday, but yeah. Troubleshoot that, and yeah, we have a subnet. So right now we can see our subnet up here, up and running. Where's my subnet address? Oh no, it's also facing the same error. Okay, 1 second. Let me see how I can fix that. Do I like demo this one? 1 second, let me just fix this on the back end a little bit, and then nope, that's worse. So you guys just give me like 1 minute to find the answer here. Okay, no, that's not it. Hold on. So I want to open my slide and find the answer, but I don't really want to show my whole slide here. So just give me a second.
No worries.
Okay, no. Does anyone know how I can like switch it around?
Yeah, I think you can just go to his.
What?
In the settings, you can go and select the screen to be 1 and 2, I think so. You want to just switch them around, right?
Yeah.
Just go back to the settings and it's on the extend display, leave it as is, and then select, just click on done after you select extend display, and then
Okay. Oh, no.
yeah, like when the option comes up, like switch those around, see if there is an option to, no, that'll just switch the position for
Okay, hold on. Did I just double click this?
I forget, like it's been a while since I used a MacBook.
Yes.
Just unplug it.
Unplug it?
That's
Yeah, okay, wait.
what we want to is come back to that setting, right?
No, it's just want to show our stuff on screen.
Yeah, I just wanna, okay, let me just unplug this and.
The practice keys on presentation.
I know, right? In times of issues, just unplug and reset.
I'll get the flat done. It's interesting.
Yeah, no, don't worry about it.
It's interesting. It's REST with Cosmos stuff. Not actually.
Well, 5.1 has a REST implementation called Forest.
Yeah.
Yeah, we do, but
Yeah.
this current version, I don't think we're running, I think we're running off the Lotus version right now.
Yeah.
Yeah. And but not Master Plus Plus was Go.
We have 2 Go and
Yeah.
debugging on 1 REST. Or at least they did 3 years ago. So you did that. No. Are you with where?
Yeah.
Near Exchange or just near?
Sometimes I call.
Yeah.
Yeah, so I work for a Go, which is development work on that show. So.
Cool. You guys are all REST, right?
Yeah. Yes. And then I do run some Cosmos validators. So.
And here is, I mean, I was trying to look this up and get verification. Yeah. Right. It's not.
Trash. REST framework.
Can I take
Taking me
it?
like 2 years.
Does it feel like modular in the sense that you could like spin off another platform with such a near infrastructure?
It's like a sharing implementation where we have this will essentially is a shard, and they're working towards sending a sharding. But yeah, if you like they've onboarded a bunch of like consumer apps and stuff there.
No, it's
And apps created today. Basically shards and stuff.
So you guys like just, it was like pretty recently you're like fully up and running, right?
Yeah, it's been like they keep upgrading the protocol that we're in like phase 3 or something, so 4. So
Yeah, I don't know much, but I worked on Rena Network at lived there for the last 2.5 years.
Yeah.
On Near the Force protocol, which is built on Near, and I've been like starting to get more and more Near updates through via the Force protocol.
It's cool. It's
Okay,
very-
so
it's
all right, thanks for bearing with me, guys. I'm just gonna, so I opened up, oh no. Basically what I did was try to open up a previous build that I have been running, that was working literally 10 minutes before my presentation. But then right now, I'm gonna try to run through the steps just really quickly here, and hopefully this is gonna work. Actually, alternatively, what I'm going to try to do is I did a manual build on this one, so let's try it without the Docker image and see what happens. So this is what happens if you use the manual build, and now we'll find out that it works fine. Yeah. So highly experimental for now.
I love it.
Thank you. Literally, our engineering team has been working super hard, putting out MVP like just this week, and yeah, we're in the hackathon, which is we do need experienced hackers to be there with us to try it out. We're also releasing like an early builders program starting mid-April. The goal is really to get people to do this with us at a way more advanced level. Have a core engineering team in. So if you want to try to build this out, a new scalability solution, we're here for you. Yeah. There's also some announcements coming in. I don't know if anyone's going for Deepin Day.
Thinking about it.
Wait, is that today? Also?
Yeah, that's today.
Maybe.
So that's run by Fluent. So Fluent is like a decentralized compute network. They're one of the first implementations for IPC. They've been building with us for the past. So whatever I explained on the custom subnet earlier on, they've been building out their custom version, which is way more like complex for decentralized compute. Yeah, so that works today. They're gonna launch that. So I'm gonna check that out.
Great.
Yeah. Okay. It's also not working. Any idea? Anyone has any idea? Do you think it's a Wi-Fi?
You trying to pull it or? That, sure.
I mean, I already did cargo release build, so like this should be up and running. I'm just trying to generate a simple wallet, and it's connecting.
Is it like on a remote, this, are you connecting to something remote on this? Are you connecting to something remote to fill the image from?
No, I actually built it locally. I did a local build.
My biggest two things is bad Wi-Fi or ports already in use. Like you may have it running in the background in another terminal or something, or like
But if it's a port issue, Docker does come an error, right? If that was
Yeah.
that port is in use or something like that, usually.
yeah.
Which is very weird. Or it's taking time to compile or run or start, whatever.
There's no way. I compiled this beforehand already. Like the manual compiled locally. And then I just did the cargo release build, so I should have released the build one more time. Okay, cool. Anyway, so we're here. Okay, so like realistically though, like what should happen is we should be able to have our subnet up and running. We have a custom subnet. Oh, you know what? Wait. Okay, guys, I know what it is. Wait. Sorry. One second. Yeah, okay, so I think I know what the issue is.
Are you running an old image or something?
No, I think I didn't fund my wallet. Wait.
Number 3. Do I have funds to do what I need?
Okay, wait, let's try that. So I'm going to go to the calibration. So there's a calibration faucet for Filecoin. If you wonder why I can put it in an OX address and get like funds, it's because we have the FEM running, which is EVM compatible. So putting in an OX address should work fine for you. So that should take about like 60 seconds. You can always check out the transaction on like a block explorer that we have. So this is Stillfox. We have about 5 different explorers you can use. Make sure that's on calibration. Okay, let's see. So once that's in, I'm just gonna prep this command and right, yeah. So this should work. Should work. Troubleshooting 101. Okay, come on. Yeah. The last time I did this with the Door Hacks hackathon, I don't know if any of you are part of their ongoing hackathon right now. Okay. The last time I did this, the thing I missed was I put in 4 validators minimum, and then I only funded 1 wallet, and so yeah, the subnet couldn't get created. Just like simple things, man. Like you think the complex stuff like Docker, you're just like done, and then you come in and you're like, I forget to fund my wallet. Okay, cool. So now we have this. Let's hope this works. Okay, we're so I don't want to put you guys through all of this. I'm hoping the wallet was fine as it was, and then just gonna try this. Take bets. Yeah. So once it's set up and if it works, there are a few other things. So I did mention this is experimental. So if you have your custom subnet working, there are a few other things that we've released too that are also experimental. I just kind of want to show you guys here. So if you come to our docs, you can also see how you can do like advanced subnet customization. So I did mention earlier on if you want to do custom syscalls, custom built-in actors, you could do that even today. Basically what you'll be doing is tweaking around with the FVM execution layer because the FVM can be, it can be like configured. So you can play around with these and set it up. So if you're keen, if you're experienced and you want to try running something more complex on a subnet, you could even do that today. We've had a few teams run ML workloads or do regional sharding, but you can play around here. A few other really new things that we've just released in the past few days are things like maybe a simple USDC exchange. Again, I mentioned, so yeah, there are some, I don't want to go too deep into it right now, but we have like USDC, you could actually burn a token on the parent subnet and then mint it within the child subnet. You could do that pretty easily. This mostly uses general message passing, but we have the contracts in here that you want to use. If you want to deposit a native supply from an Ethereum L1 into your custom subnet, you could even do so today. We have Xler. Because Xler is integrated with FVM, FVM is our execution layer, you could do it today with some easy repos that you can fork over here. So these pieces are lying around. I think by the time we hit probably ECC in Brussels, we'll have a much more ready product to go. Super open for feedback at this point in time. Our engineering team is like testing things and moving around. So yeah, so that's kind of where we're at right now. Oh my gosh, did it get? Yes, guys, we have a subnet!
Just in time.
Okay, great. Yeah, so if you have a subnet running, everything gets much easier from here on out. Where was I? Yeah, so once you got it running, super easy. You can get your wallet published, as in get your public key for your wallet, and then joining the subnets with your validators. Do you guys want me to run that through in like 3 minutes? If you have like 3 minutes, you want to see the subnet fully running with nodes?
I'm
Should be already here. So.
3 minutes? Okay, cool.
Yeah,
Let's
3
do
minutes,
it.
yeah.
Thank you guys. Thank you. Alright. So we have this. Sorry, Grace. Just give me like 3 more minutes. I'll get us off. No worries.
Is the third type delegated proof of stake? Is that kind of the third type of consensus you said it's like permissionless or stake?
Oh yeah.
It sounded like delegated proof of stake.
I think it's that. I think you're probably right.
It's called different things, but sorry.
Yeah. No, I think you're right. I just couldn't remember what the last word was.
It's okay.
Alright, so we got the key in here. And then, so we're going to join a subnet with our one validator because we did set it as minimum just one, which is good in this case because imagine we had to do 4 of these text editor things. Again, the deploy script should make it much easier. Right now it's only working on Linux, which is why I want to show it today, and also running for some bugs. But yes, where is my subnet ID? I feel like I brought like some swag for people to like get for just attending this and seeing how this can actually get done. But thanks so much for staying. Alright, okay, so here's something. So after joining to that, let me just prep the next one, which is deploying it, and then once we deploy this and run the cargo mate, we should have it up and running.
Oh, I see that second.
Which one?
Oh, the next step is, sorry. Oh, you can keep going.
Did I miss something?
No.
Oh, okay. But yeah, if this takes too long to load, just know that it was this, and then it was a validator, and then from there, once we deploy the cargo mate build, we will have a subnet up and running. Yeah. Again, if you did not miss a step on funding your wallet, you should have gotten this done within 5 to 7 minutes. Oh. No, sorry, right.
So that's a very familiar command right there to me.
What was it?
Whatever you just grabbed on the clipboard actually from the documentation.
What?
The validator create command,
Mm-hmm.
that's from the docs is, that's very familiar. The cargo make file and throw.
Yeah. Are you familiar with subnets?
Cosmos validators, it's the same.
Oh, Cosmos, yeah.
That's definitely
Okay.
Cosmos thing.
Because that would we have to spin up new validators.
Yeah.
I know, yeah. Do you guys know of like an easier way to do this? Or like, in terms of like UX?
Yeah, not on this side.
Cosmos needs a lot of UX upgrades, I always. But that's the easy way to do it, yeah.
I've seen
Okay,
some good-
I'm not going to run through this part, but yes,
Okay.
once we're done the cargo mate, you already subnet up and running, but yeah. Done! So that's
Very
it.
cool.
Thank you for staying and troubleshooting this with me. I really appreciate it.
So managing the subnet,
It's interesting.